Okay. So, all right, I will start now that we're recording. Good afternoon, everyone. Thank you very much for attending this exciting workshop that we've organized for our members. I'm going to get interrupted by all these rings as people come in. But I'm Mark Salzberg, chairperson for TRACCS Transit and Rail. I'm delighted to have Ricardo Rail present the delivering the Elizabeth line, system engineering successes and challenges. Before we introduce our guests, I'd like to just do some housekeeping messages and just give a overview of what TRACCS is organizing for all our members and how our members can participate. So, June 20th and 21st, we have our second annual Rail Day. It's an indoor-outdoor rail exhibition. For those who are unaware, this is first of its kind in Canada, focused predominantly on passenger rail and transit. Last year, we had over 2,500 people attend with just under 100 exhibitors. We hope to surpass that this year, and hopefully you can register, register for a booth, and even attend as a guest. So please go to the website and click on the link for TRACCS Rail Day 2023. There are lots of opportunities available to participate. There's the showroom and demos. There's also speaking engagements as well as a cocktail hour for after the show. So again, for those interested, please go to our website. And now, without further ado, I'm going to stop presenting and I'm going to allow Ricardo to share their screen. But first, I will make a quick introduction to our guests. Phil Barnwell is a chartered railway engineer with over 4 decades of involvement in all stages of rail projects, from concept through design to delivery and operation. Phil began his career in the manufacturing industry, moved into the whole railway system research and engineering, and then into systems, assurance and certification. Phil led a team in the UK and overseas in the successful delivery and certification of trains, signaling, and infrastructure, and is motivated to bring into service the latest technological advances in an efficient and effective manner, keeping the rail industry at the forefront of transportation options. So thank you, Phil, for making the time to meet with us. Next, we have Mike Ainsworth. Mike Ainsworth began his career specializing in safety critical software before moving into railway signaling systems and then major infrastructure projects. He has been developing and certifying safety-related systems for over 25 years. He was the lead assessor for interoperability legislation on the Elizabeth line and now heads the Ricardo office in Toronto. And finally, last but not least, Caroline Salmon is a chartered engineer and fellow of the IET with extensive experience of independent safety assessment across a range of industries, including rail. Caroline provides governance and technical oversight of the accredited assessment body, independent safety assessment, and services that Ricardo certification provides. This includes keeping the relevant manuals up to date, providing training on how to deliver such services, and mentoring staff, as well as delivering the services to some of Ricardo's key projects across UK and Canada. More recently, Caroline has been providing training to the rail industry in Canada on the adoption of the Canadian method for risk evaluation and assessment standard. Thank you, Ricardo team, and we look forward to hearing about your presentation. So Caroline, do you want to share your presentation? Thanks.
Hopefully that's worked, yeah?
Yep.
Okay, excellent. Thank you, Mark, for that introduction, and welcome to this presentation on the Elizabeth line. What we're going to cover today, I'm just going to give a brief introduction to Ricardo, and you've had an introduction on our presenters, and then I'll just tell you a little bit about the Elizabeth line itself, and then I'll hand over to my colleagues, and they will cover some particular project successes and challenges that the project's faced. We've got a bit of time at the end for questions, so if you could hold off and put questions in the chat as you go through, we'll endeavour to answer as many of them as we can. If there are a lot of questions, we're quite happy to stay on for a while after the hour, or we'll follow up with written answers to the questions that have been provided. So hopefully we will actually get to answer all of your questions. So just a little bit about Ricardo first. We're an engineering consultancy firm. We're global. We work in a number of sectors. We started out in the automotive sector, but we now provide consultancy services across environment, energy, defence, and of course, rail. Back in December 2021, we were the first organisation to be accredited in Canada to provide independent safety assessment services. That accreditation was provided by the Standards Council of Canada, and so we're formally accredited to provide work in Canada. We're very excited to be working in this new environment and to be able to support you on some of the massive investments that are in the rail industry in Canada. So we've done an introduction, so I'm not going to go through all of that again. I will say Phil was was leading the program, so Phil's our lead assessor on the Elizabeth Line development project, and Mike and I supported Phil as well as a number of other assessors. So what is the Elizabeth Line? Well, the Elizabeth Line itself is the line that is now running. During the construction side of things, the project was known as the Crossrail project. So we'll often talk about Crossrail. That was the construction project that went ahead to actually build what is now the Elizabeth Line. The Elizabeth Line is made up of existing infrastructure connected from east to west through central London to provide a service from Reading over here in the west to Shenfield and Abbeywood over in the east here. The bit in the dotted line here is actually new infrastructure, and the bit outside the dotted line is the old infrastructure. So here from sort of Paddington out to Reading and Heathrow, that's existing infrastructure operated and maintained by Network Rail. And over on the east here, heading out from Stratford to Shenfield, that's existing infrastructure operated and maintained by Network Rail. In the middle, there was a new tunnel built under central London, and it's operated by a new infrastructure manager, Rail for London. So there was new stations built in central London. There was a new tunnel built under London, which in itself is quite an impressive feat of civil engineering. We're not going to talk about that in a great deal of detail, but just to give you a bit of an idea, obviously London's quite a busy city, both on the surface and underneath. The stations in the middle there, where they've got you've got station names inside coloured boxes. They represent other underground networks or mainline railways in central London. And so, for example, the tunnelling under Tottenham Court Road had to be so precise it went within 1 metre of the existing Northern Line underground line. And so obviously there was a lot of precision and accuracy and careful planning to make sure that that tunnelling could go ahead as planned and without impacting on the existing infrastructure. So it's quite a impressive feat of engineering. It was opened admittedly a bit late, but it's been opened less than a year and is already exceeding expectations in terms of ridership and revenue. I'm just going to hand over to Mark, who's going to run a little video for you just to give a better idea or a little bit more of an idea of what the Elizabeth Line is all about. I can't do it because our bandwidth's a bit short. So is that right, Mark, if you share your screen?
Yep, just 1 second. And just going to share now, and then there we go.
Thank you, Mark, for that. If you just give me a sec, I will share my screen again. Okay, so hopefully you can see my screen again. So yeah, that gives you a bit of an idea of the scale of the project. So our role in it, we were appointed as independent assessors to the Crossrail programme. At the time of the commencement of the project, there was some new legislation coming out of Europe that would apply to the programme. It was new to Europe, and it was new to the UK rail industry. The two relevant pieces of legislation were in relation to safety and interoperability. So there was a safety directive that was supported by a piece of regulation called the Common Safety Method for Risk Evaluation and Assessment, CSMRA, which provided a process for managing hazards and making sure that your risks were controlled. The diagram on the right of the slide there, that's actually taken from CSMRA. If you're familiar, you might be familiar with that because it's very similar to the recent piece of standards that's been published in Canada called the Canadian Method for Risk Evaluation and Assessment, or CMREA. But they're very closely aligned. You've built your standard based on the European standard. So that was a new piece of legislation that came out. In addition to that, there was a concept called interoperability, which was the idea of being able to operate a train across Europe with a single technical solution. It was underpinned by technical specifications for interoperability, which actually define how you deliver this single solution railway, or TSIs. But obviously, because we had legacy railways across Europe, there were some cases where we couldn't necessarily meet TSIs. Those were known as open points. And so each member state within Europe had to come up with their own rules for how you would meet those open points. Those were known as national technical rules. So the Crossrail programme had to comply with CSM. It had to deliver a technically compliant railway compliant to the TSIs and the NTRs. What the interoperability and safety directives required was that there was independent oversight for compliance with the process for safety management and the technical compliance. And that's where we came in. So in CSM terms, the body that actually does that independent assessment is called an ASBO, an assessment body. And the technical compliance with the TSIs and the national technical rules were undertaken by NOBO and DEBO respectively. So that's what we did. We provided independent checks of what Crossrail was doing to make sure that they delivered a safe railway. Our scope didn't include the whole railway. We didn't cover rolling stock, and we didn't cover the signalling products themselves, but we did look at the integration of those products. We looked at the tunnels, we looked at track, we looked at the new stations that were being built, and then we obviously looked at integration of these various elements together to make sure that they work together, and particularly as there were existing infrastructure operated by different infrastructure manager at either end of the new bit of tunneling in the middle, we had to look at the infrastructure at those particular interfaces as well. We were involved for about 9 years, and we inspected thousands of items and raised many observations that have been satisfactorily resolved. That has enabled us to support the Crossrail programme to put the Elizabeth line into service in May 2022. I'm now going to hand over to Mike, who's going to talk about some of the successes of the project.
Okay, so for various things that went really well on the project, we picked 4 to talk about, so I'll go through these. So the first thing to say is that this was a massive project. It was £19 billion, so $30 billion Canadian. So one of the problems is how do you deconstruct that in a way to actually be able to get a grip on it. The complicated looking diagram on the right of the screen is a map of how all the different contracts came together to make up the complete railway. It was divided up into over 50 separate contracts with a top level Crossrail Limited overseeing the whole thing. And the way that they split it up into what they called framework design contracts, who did, in particular, a lot of the early civil engineering design, so the basic sort of concrete structure for various parts of the railway. Then you had the main build contracts who took over and did the detailed design and internal fit out for something like a station. And then they also had what they called system-wide contracts for things that needed to be consistent all the way down the route. So things like track, platform screen doors, things like elevators where they wanted to have the same supply in all of the stations. That was all done as system-wide contracts. And of course, each of those would then have a multitude of lower level contractors doing work on site. So those 50 tier 1 contractors, they were effectively out operating at the same level. So they were responsible for the integration within the scope, and then Crossrail Limited pulling it all together at the very top level. One of the things that they did very well was they spent a lot of time thinking about interface management. So each of the contractors had to provide a safety management plan for their scope. One of the things they had to put in there was a context diagram to show which other contracts were they going to interact with. And there were formal mechanisms in place for interface meetings, for transferring requirements and hazards and program management and coordination between all those different contractors. The other thing that they put quite a lot of thought into was making sure that when they divided things up, they didn't lose sight of the original requirements. So the top level sponsor requirements, what's called the CPFR, the Crossrail Programme of Functional Requirements, those requirements were cascaded down into all the different tier 1 contracts, so that you could trace how all of these different contracts were coming together to achieve the top level requirements. And during the course of the project, they did a number of stand back reviews where they stepped back a bit and pulled all the contractors together to check that those top level requirements were still being met. And a little bit later on, we'll talk about some places where that perhaps didn't quite work, and they needed to do a bit more work on it. So there were examples like late in the project, they started finding problems with integration between the signalling system and the rolling stocks train management system. And so they ended up putting in place a dedicated team to try and improve the coordination on that interface and make sure that the software releases were aligned and the problems were being fixed. The other thing that worked quite well was in terms of getting the railway approved for passenger operation, there's a final legal sign-off by the Office of, in the UK, it's the Office of Road and Rail. And they provide the final approval for it to go into passenger service. And the work that we were doing for independent certification feeds into that process. So it can't open until our work has been passed across to the government department to get it signed off. And the problem is that all happens right at the end of the project. So one of the things that was put in place was how do you put in place tracking throughout the project so that you've got a way of building up a picture of the assurance so you don't end up with surprises at the end. So for safety assurance, each part of the project had its own V life cycle. So each of those 50 contracts had its own V life cycle it was working through of design and construction. What we put in place in terms of the safety assessment was a simplified V life cycle with some requirements about what we thought needed to be in place at each stage of the life cycle. And then we had some traffic light reports against each of those, so each one could be marked as red, yellow, green, depending on where it was. And we could apply that diagram consistently across all of those 50 contracts, and that gave us a very simple way of reporting up to the executive level to say, this is what's going on, these contracts are on track, we've got concerns on these contracts over here, some of them are behind where they should be. So it was a very simple but powerful way of tracking the safety assurance, so that as we move through the project, we got a way of clearly identifying problems as we went along. Similarly, in terms of the technical assurance, so the work that we were doing on interoperability checking, which is more of a standards compliance check, it's closer to an authority having jurisdiction in Canada. We had all of the requirements that were specified in the legislation, again, allocated down across all of these 50 contracts, and we could track percentage compliance for each contract in terms of what have they given us evidence for. Have we seen the design evidence for this, yes or no? Have we seen the construction evidence? And we could pass those metrics through. So it gave us a very good way of running through and identifying, are we on track? Have we got any problems? Where we got any issues. So there were a few areas where it became apparent that the design of the system meant that you couldn't meet some of the original requirements or some of the requirements that were specified in European legislation. And so in some cases, so particularly if it was a legal requirement that they couldn't meet, the only people who can grant approval to do that is the government. So if they had to go to the government to get a derogation to say, for example, that the platform heights on the Elizabeth line are different to the heights that are specified in the European legislation. It's a different height because that gives us the ability to have level access boarding so that a passenger in a wheelchair can just roll straight onto the train. But because it doesn't match the European legislation, that had to go to the government for approval. And you need to know about that early on because that process takes time to go through. The other thing, sort of building on from having progressive assurance, the other bits that worked quite well was having a strong governance regime. So they had a series of stage gates that the project had to go through, similar to how a number of projects, and certainly in Toronto, a number of the projects in Toronto are going through similar sort of stage gate processes. And that wasn't particularly imposed by a regulation or a standard, but it was something that Crossrail Limited decided to do because it was best practice. And they wrote a very detailed plan of how that was going to work. And there were 5 key areas that you had to pass in order to get through each stage gate. So first level of it was engineering review. So doing a design review of submissions from contractors to say, does this design make sense? And in particular, one of the key ones was what they called the final design overview, which was effectively the end of the design stage, the point beyond which the design could not be changed any further and you were just into building. And for those final design overview workshops, that was where they did quite a good sort of stand back review. So rather than it being a detailed review of documents, it was more a case of having a team of people, including various key stakeholders, doing a walkthrough of the design to say, does this actually make sense? Does it work? Does it meet the operational requirements? Does it meet what the sponsors wanted? So that was a key engineering check. Then they had quality assurance. So all the way throughout the project, there were quality assurance teams auditing the contractors, checking what was happening, raising issues, and that fed into the stage gates. So at each stage gate, there was a report from the quality assurance team to say, this is how many open issues we've got with this contractor. Then you had the safety and technical assurance. So there were safety teams within the project doing hazard analysis, reliability analysis, there was security analysis going on, all that sort of stuff. And that was overseen what they did was they set up what they called the Railway Assurance Board for Crossrail, RABC, which had a defined terms of reference. They were the approvers of all the key safety documentation on the project. And that was run by an external chair. So they appointed somebody who was completely independent of the project. And that having the right chairperson for that committee was key to getting that to work. And then the board that they set up, again, it included some people from within the project, but it also included representations from the key stakeholders. So they included people like London Underground, who have a lot of interaction with the Elizabeth Line. So it was a very strong committee because it had a lot of external people who could give independent oversight and governance for the project. And they met on a monthly basis as the project went through, looking at how various safety deliverables were being produced and giving them their approval. Then you had the work that we were doing as the independent assurance team. So Ricardo were the independent assurance team. We were doing our own audits of the project. We were assessing all the safety deliverables. We were checking for compliance with all the interoperability requirements. And we were producing a report. So every time there was a stage gate, we were providing status reports to say, here's our view on where each of these contracts is. And all of that fed into reports going to the government regulators. So although the government regulator only had a formal decision at the very end of the project, there were regular meetings throughout the project with the regulators so that if there was anything where it looked like there was going to be a non-compliance, we got the opportunity to discuss that with the regulator and saying, yeah, is this going to be okay? Can we get a derogation to do this because we've got a very strong argument for why it's being done this way? Or is it something that, you know, we are just going to have to go back and change the design and fix it? And final point on success before I hand over to Phil to talk about some of the more complex areas. One of the things that Crossrail did very well was working collaboratively. So they had very strong communication of the goals. So it was a very public project. You know, so BBC Television were making a film of the project. So there were bits of it where it was being broadcast on television. It was in the press a lot. They had regular staff days where they pulled everybody together to get the senior leadership to say, this is what's going on the project, this is the strategy going forward. At a more local level, there were toolbox talks where department heads would have meetings with their departments to talk about key messages and what was happening around the project. So they had very strong publicity, both externally and internally. There was lots of good interworking between the different projects, lots of workshops going on to troubleshoot issues. Because a lot of the legislation was new, I spent a lot of time going round some of the contracts and explaining to them how the legislation worked, you know, what independent assurance was doing, how we expected to receive evidence from them, all that sort of stuff. So we did lots of interworking. They had common tools and techniques. So in particular, things like document management. Every single contract was using the same document control tool, which was a tool called EB. We also had access to it, so we could go and find any documents from any contractor. So unless it was something that was specifically restricted for security reasons, all of the design documentation, all of the drawings, all of the reports, we could just go into the document control system and find it, and so could everybody else on the project, which made it very easy to go and find things and check things. The core team was all co-located, so they had a headquarters building in London, where there were representatives from most of the tier 1 contractors within the headquarters building, along with Crossrail Limited. We had a core team in there as well for our independent certification work, and then a wider team of about 20-30 people who got pulled in as needed. But we always had some people in the office with the project team. They had a strong program focus, so regular meetings to get programs updated, find out what was going on. They had some good systems for contingency management. So there were places where the projects didn't go to plan, and they had to find ways of dealing with that. As an example of that, they had one station, Bond Street, where there were some construction problems and some contractual problems, which meant that station just was running very, very late. In the end, what they did was they opened the line without that station being open, and we had a discussion around safety arrangements and agreed that it was good enough to be used as an evacuation point in an emergency, but it was closed to the public because there was still fitting out work happening in the station. But that meant that the line could be opened, and then Bond Street Station opened a few months later. I think that's probably as much as I need to say, so I shall hand over to Phil.
Carolyn, Mike, thank you for setting the scene. Very little else I can add, but I will. So we are actually just finalising that engagement that started back in 2012, and which I joined in 2014. And the line itself should be complete by May of this year, and I'll go into what remains a little later on. Similar to Mike's approach, I want to look at these 5 areas, selected those, their challenges that the project met and obviously overcame. There are only a few of the very many that the project successfully tackled in its journey to opening. And they each have elements of newness, novelty and complexity in them. So there were a focus for Crossrail and for ourselves, each following the application of CSMRA, as Carolyn pointed out, and CMREA for yourselves in Canada. Very useful, and I think just bear that in mind: newness, novelty, complexity, NNC as we called it, a very useful method for identifying risk within the programme. So can we go on to the next slide, please? So 2 major parts to the overall programme. There's a civils element. That's a large part of the work, it's a large part of the budget, and it's a large part of the programme. And importantly, of course, it has to be substantially completed before you can actually start to pull together the elements that make up the railway. So let's just remind ourselves of what those elements are that make up the railway. Mike had run through them. The civils elements of tunnels, stations, shafts, track. The systems, mechanical and electrical systems, signalling, power supplies, communication systems, and of course also the rolling stock. And then, and just as important, people, processes and procedures for the people who are going to actually operate the railway. All of that has to be brought together for a successful opening. So what has to be worked through once the railway is once the civils is sufficiently advanced are a number of discrete stages: verification of the specific requirements of each of those elements we've just gone through, verification at an integrated level, demonstrating they're working together, then trial running, a formal stage confirming that the 4 pillars of assurance are in place, that the railway is accepted to be safe, operable, maintainable, and of course performing to the spec. Then trial operation, which is timetabled running as if the service is actually in service. There will be changes. Inevitably, there will be changes, and they have to be resourced and fitted into the program. And the program needs to be risk-based, based on NNC, of course. And then there needs to be reliability growth. And that's the point at which you get the confidence the railway is actually ready to open. So the key points, I think, to take away are that that process of going through those stages I've just described is not really compressible. So the program has to cater for each of those. But of course, what often happens is the civils runs late, and everyone is then looking at how they can compress those stages and still open on time. Also worthwhile noting that modern railways are digital, heavily digital. Just about every element of this railway is connected together by the comms system. And so the comms system inevitably becomes the last piece to be fitted into the jigsaw. And for the Crossrail Railway, or the Elizabeth Line as it now is, that process is still only now being completed. I'd like to look now just quickly at the overall program. So if we can move on to the next slide, please. So I'm going to run from, obviously, from left to right. That first period in black, what it showed was the period from 2001 when Crossrail Limited was brought into being, and then it working to detail the design to the point at which royal assent could be secured, and the bill, the Crossrail bill, put on the statute books to enable ground to be broken. Groundbreaking started at Canary Wharf because that was actually a commercial and retail project largely, and it was waiting to get started. So it was one of the first visible elements of the railway making progress. And then in 2012, the tunnelling started, and you saw the tunnel boarding machines being dropped down the shafts, ready to board in the video that we saw. Then we moved into stages where you could actually, well, Mike mentioned, no, it's Carolyn, I think, mentioned about RFLI, the operator for the future railway came on board, RFLI, that was in 2015, and our engagement then extended from both CRL and also to RFLI as well, and its preparations for opening the railway. Importantly then, we moved to the blue section there, and towards the end of 2017, the civils were sufficiently advanced for the power to be switched on and for wheels to start to turn. So at that stage, people were able to look encouragingly at the railway being open in a year's time at the end of 2018. But of course, as 2018 rolled on, it became evident that that would not be achieved. So what happened late in 2018 was the responsibility for the programme transferred from Crossrail Limited to TfL, ultimately the end point operator and owner of the railway. And with no let-up in pressure, those tests that I had run through, particularly trial running, carried on whilst TfL rebaselined, replanned, reprogrammed. And that's the period 2018. And that testing, those series of tests that I went through, occupied the time through until 2021. And one of the points to bring out, of course, as Mike pointed out, was in looking at the programme and how they could open the railway, a stage 3A was developed, which was without Bond Street, one of the 8 subsurface stations, and also without certain other functionality. And yes, in that period there, of course, we also had COVID. And what I need to point out is that it was very impressive the way the project managed to keep the programme on time. And I think we lost months, but certainly not years during that period. But the key point to bring out here is to look at when the power was first turned on and wheels started turning, which was at the end of 2017, and when the railway actually was ready to open in 2022. So can we move on to the next slide? Thank you. So what I wanted to bring out from this slide was four early decisions concerning the railway that played out towards the end of the programme. So the first was the very complicated ventilation and evacuation system, which was installed and optimised. But what it was then found was when the train started running and the various scenarios were run through, there was an interaction between the tunnel pressurization and some of the doors, the platform edge doors and some of the evacuation doors. So what that required was that huge piece of work in optimizing the design having to be revisited in that 4-year period during the stages of trial running. Platform edge doors. These are installed on the subsurface sections, but they were not installed on 2 of the surface stations which form part of the central operating section. Good reason for that. I'll not go through at this stage, but what it unfortunately also led to, though, was there is a function called auto reverse, which enables the trains that run only in the central section to be reversed at each end of their journey, and to do that whilst the driver traverses from one end to the other of the trains. At the western end, that's done adjacent to the national network, and special arrangements have been put in place to enable that to happen. But at the eastern end, it actually passes past one station and enters into a station without platform edge doors. And that has set some challenges which have yet still to be addressed by the project. There are 3 signalling systems, and there's a very good reason for there being 3 signalling systems, and we will look at that in the next couple of slides. But as Mike had already intimated, it did lead to some integration challenges, and those were only again identified and had to be worked through in that period when the testing was underway from 2018 through until 2022. And then there were power supplies for maintenance stabling yard on the eastern side, and those power supplies were derived from the main line, a very sensible arrangement, except that obviously during night maintenance, you wanted to turn that power off, and that meant that the yards went dead, with the impact on cleaning services and preconditioning of those trains. A temporary solution has been put in place. The final solution is still being worked upon. So what I think the message, the key takeaway here is apply an NC, look at the newness, novelty and complexity, and ensure that your program has is managing the risks appropriate to the scale of newness, novelty and complexity in the systems. So can we run on to the next slide, please? So here are the 3 signalling systems. So at the eastern end, so that's towards the right in blue, upper, we've got the legacy signalling system, TPWS, train protection and warning system. That's on the surface. Then on the left-hand side, we've got the western surface section of the line. That has got TPWS, and it is rolling out the program of the European Train Management System. That's two systems we now have. And then we have the central section shown in green here, and the decision, quite rightly, to use a communication-based signaling system in the center to deal with the challenges of the intensity of operation there. All perfectly justifiable, but setting a real challenge for integration within the project. So can we go on to the next slide? Thank you. Mike spoke about the importance of gates, milestones and gates set throughout the program. This is a 20-year program, and typically something approaching yearly gates to ensure that each of the stages is met, and that all of the elements that make up those are all lined up. However, inevitably at those gates, you are going to have some misalignment, and that is identified in dependencies that you carry past the gate. All perfectly sensible to plan for, as long as those can be managed, but they do need to be planned. So I've listed here a number of elements which Crossrail put in place to ensure that those dependencies were not just forgotten about and pressing on with the work of the next stage, but that they were carried with the program and managed with the program. So a dedicated dependencies management team, tracking the closure rate, and this was carried out from the executive level down. Everyone was aware of the rate, the burn down rate on dependencies, and a target rate of closure was set and was fiercely held to. Nevertheless, whilst you are operating with those dependencies, almost certainly there will need to be additional controls put in place. There was a defined method for operational restrictions and also for putting in place interim maintenance arrangements. And finally, particularly from a safety perspective, there was a defined method for determining the residual risk and determining that that was actually acceptable at each of the gates. So to conclude, CSMRA was applied successfully and with value, and it necessarily requires the identification of newness, novelty and complexity, and must lead to a proportionate focus on risk management within the programme. The second is safety and programme risk are inextricably linked. So don't think that safety is something separate. The two are inextricably linked. And the third is that those layers of assurance that Mike identified within the pyramid that he showed must align at all the programme gates. That's to ensure that you don't have the situation where you've got a railway that's ready to open and the paperwork is holding it up. The paperwork must stay in line with the programme. So that said, I think everyone recognises the railway was a success. One of the tests in London is to look to the London Evening Standard, the main paper there, and its test is what headlines it rolls out. And throughout the programme, the London Evening Standard was very positive, and here's a couple of the headlines about the Elizabeth line hitting its targets. But probably the most important success of all was the fact that our much-loved Queen was actually able to open the line, and it was one of the last of the duties she carried out, and clearly she was very pleased to have been able to do that. So, Chair Mark.
Well, thank you, Ricardo team, for an excellent presentation. It was really fascinating and interesting, especially for such a complex, large, long project like the Crossrail. So Really, thank you very much. I know that there's some commonalities that are happening in North America, and especially in Toronto, with some of the complexities and challenges that we face with these large projects. So we welcome this input and welcome this information sharing forum. So thank you very much. I am going to do a couple of house cleaning items just before we get to some questions. Once again, we do have our Rail Day coming up in June. We also have a list of workshops that are happening in the next coming weeks and months. I would highly recommend that you go to TRACCS.ca to register right away. Also, we have an exciting opportunity for a Czech Republic Canadian rail delegation, where we will be meeting with a number of transit agencies from around Czech Republic, interacting with them, and we're just setting up some workshops on lessons learned and best practices, and just seeing if there's any opportunities to collaborate and just engage further. So we already have a few transit agencies attending, and we welcome our members to attend as well. Please email Jen Bizensky at jenb@traccs.ca for more details. We're really excited that this is happening. It's happening in early June, so just in time before Rail Day occurs. All right, now back to some questions before the time is up. Unfortunately, we only have 6 minutes, but we'll try and ask as many. We'll do some quick fire questions and see how many we can answer. So how did you manage, Josh Strub just asked, how did you manage to develop the requirements derived in a Tier 1 contract that needed to be transferred to another Tier 1 contract? And one minor follow-up from Anne O'Neill, how are interface requirements managed across Tier 1s or between Tier 1s and the system-wide contracts, including for testing these interfaces?
I'll have a go at answering that. So all of the requirements work lived indoors. So in terms of the requirements allocation across the contracts, if I do it in terms of some of the interoperability requirements, because that was the bit I spent most of my time looking at, a requirement for something like safe evacuation from a train, that involved requirements that applied to the tunnels, in terms of the tunnel walkways, and then through into each of the stations. And so what we were doing was, within doors, we could allocate the same set of requirements to all of the contractors that potentially had that requirement in their scope, and then they had to feed in evidence to show that they'd met that requirement for their piece of railway. In terms of the interface management, there were interface control documents between the contractors, and they had mechanisms within doors for transferring requirements between people. In terms of integration testing, the contractors had to agree who was responsible for testing each. Where you got an interface that involved two contractors, they had to agree who owned the interface in terms of the testing of it. And then ultimately it rolled up into some of the high-level integration work that Crossrail Limited got involved in, particularly things like some of the very complex stuff like integrating all the different signalling systems onto the train, where it became clear that there were just a lot of issues to deal with, and so they put a dedicated program management team in place to troubleshoot it.
We can't hear you, Mark.
Thank you, Mike. There is another question here asked about risk acceptability. What was done in terms of risk acceptability for the project overall and at the subsystems level? Were there any quantitative safety targets to be followed?
Phil, that sounds like a question for you.
It does, and I'm racking my brains for a good example. Yes, there certainly were quantified risk assessments done, and if I recall correctly, yes,
there was an overall risk model of the complete railway was done. So at the level of Crossrail Limited, they did have a quantified risk model of the complete railway, so that they could look at how various options might affect risk. That was mostly done because in the UK, that the UK Rail Safety and Standards Board has a risk model of the whole of the railway that you can use as a starting point. But yeah, in terms of the practical stuff, I mean, when they produced the final safety justification for various phases, that was where the RABC endorsements to check that the level of residual risk was okay became really important. Do you want to say any more on that, Phil?
I think I was only going to add that obviously applying CSMRA, where they had identified significant newness and novelty, then they were applying explicit risk estimation. And there were some 50 odd cases, if I recall, identified within their overall safety argument where the onus was then on the project to carry out quantitative or at least qualitative and potentially in some cases quantitative risk assessment to demonstrate the overall acceptability of risk.
Thank you. Thank you very much. I have another question here. What were the key challenges to overcome with the system integration being both a greenfield site for the new sections and brownfield system for the existing stations and tunnels?
So in terms of system integration, so the brownfield part is more the outer sections, so the bit where it interfaces onto the existing network rail lines. And there were some issues there in terms of things like platform height is different. So in the Crossrail central section, they went for a different platform height because it gave them level access boarding. Well, that means when you run the trains out into the older stations on the network, you've got to make sure that the platform height difference is acceptable. There were lots of issues around. Phil mentioned the auto reverse. So when the trains come out of the central section at Paddington, there's then an area where that they have to do the auto reverse operation. There was a lot of discussion there around the operational safety for maintenance staff, because it's a very complex area of railway. It's the interface coming into Paddington Station, so you've got a huge expanse of tracks. It's like coming into Union Station in Toronto.
And I think pointing out it was two maintainers at that point as well, because you've got Network Rail as well as the new infrastructure manager. So complexities over understanding how that was going to operate.
So trying to make sure that everybody was aware that there were now driverless trains operating in this area and making that safe involved a lot of discussions.
Well, thank you very much. I understand that some people may need to leave. We are already at 2:31. I would like to again thank everyone who Phil, Carolyn, Mike, you took so much time and prepared such a wonderful presentation. I'm receiving comments here already thanking you for it. I have left on screen your emails, and that's already being shared with the participants so they can ask you more questions, because there's way too many for us to respect the timeline here. I think that's always a good thing. And we have people raising hands. I'm gonna ask if you can text right in the chat box your questions or comments. For those of you who have a moment to stay, I want to share with you what other webinars are coming up. So we have next week on April 5, a webinar on cybersecurity for transit systems operators, offered by WGD Consulting. And it's on applying Apta's cybersecurity recommendations to transit operational technology. Really important nowadays, we all understand that. It's on a regular 12 noon Eastern time frame, April 5. And then soon after that, April 20, we have another webinar, Data from Trees to Tracks, how utilizing data can keep boots off the ballast, drive efficiency, and save money. This will be offered by Summit Infrastructure. We're already having people register for these webinars. This is all on our homepage, www.traccs.ca. Please stop by and register. And going back to what Mark mentioned, Rail Day, we are registering booths. There's still some sponsorship opportunities available, speaking opportunities as well, and we will have a cocktail this year. We're engaging more people, more speakers, more exhibitors. Don't miss it. It's going to be really good. More information is all on our website. We thank you all very much for being here. And now I gave people time to text, more questions that can be addressed for you. Thank you, very good presentation. So I think that we can all leave you now with our enormous gratitude.
Thank you.
Okay, thank you.
Thank you for listening.
Thank you very much. Have a wonderful rest of your day.
Thank you.
Thank you.
Thank you.